right, let's hear your thoughts. What did you think the domain of G or F was? I'm sorry, number one. We're doing number one. What did you think about the domain of F? Charlie.
I think it's 8 with a closed dot, and then, or sorry, -8, my bad, and then up, and then it's forever.
And then forever. So in terms of like writing that down, maybe -8 to infinity. Makes sense to me. That's pretty good. Now we also need the range of that function. So stop and think what that looks like. That is a square root function. So won't that look like this, starting over here at -8? So that means its range is 0 to infinity. That was another question down the line. What's the range of that? Okay, now what about G? What's its domain? Everything except 2. So on the number line, we'd have an open dot at 2, and writing it out is kind of a pain in the butt, but it would look like that. I went ahead and made the composition H was G of f of x. So Y said this. Is that what you got for H? Now we got to talk about its domain. Okay, now look at this carefully. Would you still agree that x has to be bigger than or equal to -8? Yep, so whatever else is going on, this is what I got. So not or equal to, can't even be or equal to. Just bigger than -8? Because now it's in the denominator. Oh wait, no, I know it can be equal because I'm subtracting 6. So if I put in -8, I would get 0 minus 6. That would still be okay. All right. Is that it? Why not? That is not it. Let's start. This guy right here, 3 square root 8 plus x minus 6, cannot equal 0. Which means 3 root 8 plus x cannot equal 6. So root 8 plus x cannot equal 2. So 8 plus x cannot equal 4, which means x can't be -4. So we have a gap in our picture at -4. Now, you might be wondering, well, wait a minute, Mrs. Ford, G, in function G, x couldn't be 2. And that is true, but I want you to stop and think about when you built this composition, you weren't concerned about the domain of G, it had to focus on the f function. And that's what gave you this. 2 is perfectly okay, I can plug 2 in here. I'm no longer plugging 2 straight into the denominator. It's going into this radical, making part of the denominator. So your domain hinges on the domain of the original. It can't be less than -8, period. So the domain of the original and the domain of the composition. That intermediate step, that G function, doesn't really matter in terms of the domain of the composition. Okay, so for your domain of this one, I hope you put -8, 4, and then 4 to infinity. Is that all right with everybody? All right. How about this next one here, when you were interpreting the function? So K of W is the number of kids, W is the week, C of K was the number of counselors, and K is the number of kids. All right, so what did you think this means? What does this mean?
I have a question on the last one real quick. Is it supposed to be -4 or +4? For your domain of H?
Oh, negative. Okay, so what does this mean? the 4th week, we need 58 counselors. That's what that means. Do we have any idea how many kids we have? No. We just know in week 4 we need 58 counselors. Okay. What does this mean? Remember, okay, it says, remember, let's say K of 10 equals 50. I'm making that up. But that would be K of, in 10 weeks, we have 50 kids, right? Or in week 10, we have 50 kids. So when I did the inverse, that's 10 comma 50. So when I did the inverse, K inverse of 50 would be 10, right? So that would be 50 kids, and it would produce the week. So this is the week that had 126 kids, right? Which function would output the number of kids that could be monitored by a given number of camp counselors? Charlie?
C of -1.
Well, we say
I'm
C
sorry,
inverse.
C inverse.
C inverse, exactly. Because C gives us the number of counselors for K kids. So the inverse is going to give us the number of kids for C counselors. Good, very good. All right, station 3. I don't have it written down here yet, but we just have answers. Did anybody get an answer for A?
7.
So I got 7. 7? Good. Write an equation. Can someone read me your equation for problem 3B? F of g of x. What did you come up with for an equation?
I got 25x squared minus 80x plus 64.
I got plus 67. Oh, yeah.
Oh, I forgot my plus 3. Yeah.
So I got plus 67. Is that okay with everybody? All right, can somebody read me, oh no, never mind. What is the answer to C?
27.
Negative 27, beautiful. And how about your equation for g of f of x?
Squared
What I got. Everybody good with that? All right, finally, station 4. Have something like this on your quiz tomorrow where you've got information given in different ways. A picture, a table, an equation, and making all this stuff. So what did you get for A? 5. How about B? 4. Oh, I love it when you talk in unison. How about C? 5. And D? 2. Very good. E?
6.
And F?
5 through 17. Square root of 39.
Okay. Either I am wrong or you are wrong. Let's do F together. So what's H of 2? I'm going to start there. H is my chart, so H of 2 is 4, right? And now I need F of 4, and F is my picture. So F of 4 is 3. And then I need G of 3, and that is my equation. So that's going to be the square root of 14 times 3 minus 3, which I think is root 39. So those of you that got something else, did you find your mistake? Yeah. Okay? All right. Let's turn it over. Station 5. Is H an invertible function on its domain? Explain why or why not. So what we mean, okay, first of all, let's be clear. If you give me an equation, a function, y equals blah, 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 I can find the inverse all the time. The inverse can always be found. when we say, is it invertible, what we mean is the inverse a function? Okay? And we talked about this a little bit. If we start with a parabola, for example, opening up, its inverse would look like this. In other words, it's not considered invertible because the inverse is not a function. So do you remember what we did? We restricted the domain and said instead of doing all of x squared, we'll only do the positive part. Then when I do the inverse, I get a function. So that would be considered invertible. So they said you got this function for x bigger than or equal to -2. Here's what I want you to do if you haven't already. Get your calculators out. And I want you to just go ahead and graph h. Just on your calculator, graph h.
Oh, yeah.
Just grab it in a standard window, so Zoom 6, a regular standard window. And then you get something that looks a little bit like this. Okay? Now, that is a picture of the entire h function. Does that pass the horizontal line test? No. So that thing right there as it sits is not invertible. However, they restricted the domain to greater than or equal to -2, which means they're only looking at this part of the function. Is it invertible? Yes. Its domain, break this down, its domain is -2 to infinity, and its range is 0 to infinity. Did you agree with that? So without doing anything, I can answer question C. This is the domain and range of the original function. So what is the domain of the inverse? Yeah, this is the domain of the inverse, and this is the range of the inverse. Okay. Now let's find the inverse. Let's graph it and see if that came out. So what is our inverse going to be? There's our function. So x equals 3y plus 6 to the 2/3. How am I going to get y by itself? First of all, I got to get rid of that. So I'm going to raise both sides to the 3/2 power, because that'll get rid of it. It's like cubing and then square rooting. So x to the 3/2 equals 3y plus 6. X to the 3/2 minus 6. And then divide by 3. Alright, now type that into your calculator. And see if you got this as the domain and this as the range. When you type that picture in your calculator. Is the domain all positive? And is the range from -2 up? Don't you love it when all the pieces come together? Okay, station 6. What did you say for f of x? We're taking our score and adding 5 bonus points, so that was x plus 5. And then g, we're giving it 7% extra, so that would be 1.07x. that on 7%, multiply by 7. So did anybody plug 75 into G, get that answer, and then plug it into F? Anybody get a number there? 85.25 is what I got. Yep. And then the other way around, plug 75 into F, and that answer into G, 85.6. And it says, which one would you rather have applied to your test? Well, I'd rather have the second one applied.
Wait, what do they mean context? Like,
Okay, so when we did D, we got 85.6. So that means that we got our 5 bonus points first, and then increased our score by 7%. In C, we increased our score by 7%, and then added 5 onto that.
I see.
Okay? This is kind of like compound interest. It's better to add the 5 back in, or add the 5 in first, and then do the 1.07. Does that make sense to you? Okay. Station 7, anybody get that one? A, B, C, or D? You got this one? D, what was your logic?
If it kept getting bigger past 2, then inside the radical imaginary, so I just chose the one to stop at 2, and it was smaller every time.
So run that by me again.
So inside the radical couldn't be smaller than 2, or couldn't be smaller than 0.
Yes.
And so I found what would be 0.
That was 2. Okay.
And then
So your pivot point, or I don't know what to call it, your like beginning point is gonna be a 2. Got it?
And I found that since x would be negative, or it would have a negative, multiply by negative, it's getting smaller.
Okay. So let's listen to Leo, all right? Leo says, I am going to be plugging G into F. So I'm going to be taking something, plugging it in, and taking the square root of it, right? So whatever I plug in has to be positive. So when I look at G, 2 is what gives me 0, right? So my picture is going to start at 2. So it's either B or D. Then, because what I am plugging in to F has to be positive, doesn't that mean my x's have to be less than 2? So the parentheses is negative times another negative would make a positive? Yeah.
We just plug that into our calculator?
You could have, yeah, if it was a calculator question. Yep. Did it turn out to be D?
Yeah.
And then station 8, here we go. Be careful. G is drawn. G is drawn. F is its inverse. Okay? So we want to know the minimum value of the inverse. Anybody get an answer there? Get an answer there? -5. Explain why you got -5.
I just did the opposite of the ones.
So remember, remember that the inverse is going to take all the ordered pairs and switch them. So, I mean, you can write some ordered pairs if you want. That one of them is -5, -3. Another one is -3, 3, and so on, right? Those are the ordered pairs. The inverse, these are G. The inverse would be -3, -5, want the smallest y value for the inverse. Well, isn't the smallest y value for the inverse going to be the smallest x value of the original? So, what's that for 3? Negative 3. Negative 3. Because you want to know what x gives you 3. What x gives you 3? Well, you look at the picture, negative 3. So then the inverse 3. And what's the domain of f? The domain of f is going to be the range of g. And the range of g is negative 3 to 7. So negative 3 to 7, so we don't get myself ultimately. That's why I set negative 3 to 7. Perfect. Okay, let's get our notes out and just scratch the surface of 2-9. The moment you've been waiting for is here. We're going to talk about some logarithms. Okay, so the inverse operation for addition is subtraction. The inverse of multiplication is division. The inverse of cubing is cube rooting. The inverse of exponents, logarithms. Okay, logarithms. When we write an exponential expression, it can be rewritten in its logarithm form, okay? So just as we can write things a number of different ways, we can write equations in exponential form or logarithmic form, okay? We're not changing the problem, we're just switching back and forth. So, this example is, here's an exponent expression. That is the exact equivalent of log base b of c equals a. Now, when I learned this a long time ago, my teacher called it loop-de-loo, and that's how I remember it. I don't know if you remember, I don't know, log rolling, I've had different ways of talking about it. But you can always rewrite a logarithm as an exponent. We don't very often go the other way, but we do this a lot. B to the 8th equals C. These two are exactly the same expression. Vocabulary, this is the symbol for log base 10. They're called common logarithms. Any idea why they're called common logarithms?
The base is 10.
Base 10 number system, absolutely. Logarithms were originally developed for computational purposes. Your calculator is a logarithmic machine. It does everything with logarithms. Since our number system is base 10, there you go. We also have ln, which is the symbol for log base e, and those are natural logarithms because e is a naturally occurring phenomenon. All right. Convert the following equations from exponential form to logarithmic form. A will be log base 3 of 9 equals 2. B will be log base 10 of y equals x. Log base r of w equals t. And log base e of y equals 3x.
Should you do the logarithm or should you do the
You can write log base c, but, and I said that because that's what comes out of the problem, but the symbol is ln. Alright, now the other way around. 7 squared equals x. 3 to the x equals y. 10 to the second equals y. And e to the fourth equals c. You all right with that? All right. Example 3, we gotta be able to do without a calculator. Let's get as many of them done as we can. Think of them as equaling x. You wanna know what they equal. So a literally says 2 to the x equals 8, 2 to what power equals 8. So the answer to a is 3. B says 5 to what power is 25, so B is 2. C is 5, very good with that. D is 2 because it's log base 10, so it's 10 to what power is 100. Uh-oh, E, 1/2, very good. 16 to the 1/2 is 4. F, 0. 3 to the 0 is this 1. G, 1. And H. -2. Or all stars. We'll stop there. Tomorrow we'll get our calculators out. Good work.
I don't think I
All right. Have a great day. I will see you tomorrow. Not Friday. We have late arrival or something on Friday.